Imagine a world where the plastic items we use every day, car dashboards, phone cases, water bottles, shopping bags, are no longer made from fossil fuels, but instead from plants. A world where the plastic that fills our landfills, chokes our oceans, and seeps invisibly into our bodies could be replaced with renewable, biodegradable alternatives. This vision, once a distant dream, is becoming increasingly tangible thanks to the rise of plant-based plastics, or bioplastics, which are derived from renewable plant materials like corn, sugarcane, and potato starch. The global plastic crisis is one of the most pressing environmental issues of our time. Every year, millions of tons of plastic waste accumulate, causing immense harm to ecosystems, wildlife, and human health. Plastic pollution is pervasive, covering beaches, floating in oceans, and breaking down into microplastics that enter the food chain. Traditional plastics made from petroleum are not only non-renewable but also extremely durable, persisting in the environment for hundreds, sometimes thousands, of years. Recycling efforts, while important, remain limited in their effectiveness. Only a fraction of plastic waste is actually recycled, and production continues to grow, fueled by cheap fossil fuels and ever-increasing consumer demand. Enter bioplastics. These innovative materials offer a glimmer of hope in the fight against plastic pollution. Derived from plants that can be regrown annually, bioplastics promise a renewable alternative to finite fossil fuels. Some bioplastics, such as polylactic acid, or PLA, can even biodegrade under specific industrial composting conditions, breaking down into water, carbon dioxide, and organic biomass. Unlike conventional plastics, which linger in the environment for centuries, PLA and other biodegradable plastics have the potential to return to the soil, reducing long-term waste and environmental accumulation. The production of plant-based plastics often generates fewer greenhouse gas emissions compared to traditional petroleum-based plastics. This means that, in addition to reducing plastic pollution, bioplastics could contribute to mitigating climate change, a dual benefit that makes them particularly attractive in the context of global environmental goals. Imagine replacing single-use plastic bottles with biodegradable versions made from sugarcane, or creating car interiors and consumer electronics from potato starch-based materials. The environmental footprint could be dramatically reduced, and reliance on oil would decrease, helping shift the industrial economy toward renewable resources. However, the transition from petroleum-based plastics to plant-based alternatives is far from simple. While bioplastics are promising, they are not a perfect solution. Not all plant-based plastics are biodegradable. Some require very specific conditions to decompose, such as high temperatures or industrial composting facilities. In natural environments like oceans or regular landfills, these plastics can persist almost as long as conventional plastics. This means that while bioplastics may reduce long-term waste in controlled environments, they cannot single-handedly solve the global plastic crisis. Large-scale manufacturing of bioplastics also faces significant challenges. Currently, production costs are higher than conventional plastics, making widespread adoption economically challenging. Performance is another concern. Certain bioplastics may not match petroleum-based plastics in durability, heat resistance, or flexibility, which limits their applications in some industries. For example, in packaging for hot or greasy foods, or in electronics that require long-lasting materials, traditional plastics still dominate. Manufacturers and researchers are working to improve the performance of bioplastics, but the transition is gradual and requires investment in new technologies and industrial processes. Land use is another critical factor. Plant-based plastics are made from crops such as corn, sugarcane, and potatoes. Scaling production to meet global plastic demand could compete with food production, raising concerns about sustainability and potential impacts on food security. It's a delicate balance. We want to reduce fossil fuel reliance, but not at the expense of feeding a growing population. Researchers are exploring alternative feedstocks, such as agricultural waste, algae, and non-food crops, to address this challenge, but widespread adoption is still in development. Importantly, the environmental benefits of bioplastics do not automatically make them harmless. Certain types may contain toxic additives, or their breakdown products could cause harm if not managed properly. Without proper disposal systems, composting infrastructure, and recycling mechanisms, bioplastics could still contribute to pollution. Simply swapping petroleum-based plastics for bioplastics is not enough. Systemic changes in production, consumption, and disposal are essential. The broader environmental context also matters. Reducing plastic pollution requires a multi-pronged approach that includes minimizing single-use plastics, improving recycling systems, encouraging reuse, and designing products for a circular economy. Bioplastics fit into this framework, but they are not a standalone solution. They are part of a larger strategy aimed at reducing overall plastic consumption, lowering greenhouse gas emissions, and building sustainable materials systems for the future. Despite these challenges, bioplastics represent a significant step forward. Countries and companies around the world are investing heavily in research and production. From biodegradable packaging and disposable cutlery to plant-based automotive parts, the applications are expanding rapidly. Innovations in materials science are improving durability, biodegradability, and cost-effectiveness, gradually narrowing the performance gap with traditional plastics. These developments signal a promising shift toward more sustainable manufacturing and consumption practices. One of the most compelling advantages of bioplastics is their potential to integrate into circular economies. In a circular system, materials are designed to be reused, recycled, or composted, rather than discarded after a single use. Plant-based plastics can play a key role here because when designed correctly, they return nutrients to the soil or can be remanufactured into new products. Unlike conventional plastics, which degrade into microplastics that persist indefinitely, bioplastics can potentially close the loop, reducing environmental burden while supporting renewable resource cycles. It's also worth noting that public perception of bioplastics is evolving. Consumers are increasingly aware of the environmental impacts of conventional plastics and are demanding sustainable alternatives. This demand drives companies to invest in bioplastics and incorporate them into their products. Retail, packaging, and food industries are experimenting with plant-based alternatives, and some large-scale brands are already replacing single-use plastic items with PLA, PHA, or starch-based products. The momentum is building, and awareness continues to grow. However, consumer education is critical. Not all bioplastics are created equal, and misconceptions can lead to improper disposal. For example, compostable plastics require industrial composting facilities to break down efficiently. If they end up in regular landfills or waterways, their environmental benefit is greatly reduced. Clear labeling, public education, and infrastructure development are essential components of a successful bioplastic transition. The environmental and societal impact of plant-based plastics extends beyond pollution. By reducing reliance on fossil fuels, bioplastics can help mitigate climate change, conserve natural resources, and support rural economies where feedstocks are grown. Innovations in algae-based or waste-derived plastics also show potential for minimizing land use competition and creating new opportunities in sustainable agriculture. As technology advances, we may see a future where plastics are produced from waste products, closing the loop even further and enhancing the circular economy. Even with these promising developments, it's crucial to maintain a realistic perspective. Bioplastics are not a universal solution, and over-reliance could create unforeseen consequences. They must be integrated into broader environmental strategies that address consumption patterns, waste management, energy use, and ecological preservation. When used thoughtfully, bioplastics can reduce our environmental footprint, but they are just one tool among many needed to tackle the global plastic crisis. The shift to plant-based plastics represents a hopeful narrative in a world grappling with plastic pollution, but it is a nuanced journey. It reflects the complexities of sustainability, where technological innovation, environmental awareness, economic feasibility, and ethical considerations intersect. As research and industry continue to advance, plant-based plastics could become mainstream, helping humanity reduce waste, lower emissions, and foster a healthier planet. In conclusion, plant-based plastics provide an opportunity to rethink how we produce, use, and dispose of materials. They illustrate the potential of renewable resources to replace petroleum-derived plastics, offering a pathway toward sustainability. Yet, they also remind us that no single technology can solve systemic environmental problems alone. Bioplastics are most effective when combined with responsible consumption, robust recycling systems, circular economy principles, and thoughtful industrial practices. The promise of a future where our plastics are renewable, compostable, and environmentally responsible is within reach, but only if we approach it with balance, awareness, and long-term vision. By integrating plant-based plastics into our daily lives, supporting innovation, and making informed choices, we can begin to transform the materials around us. The journey is not just about replacing one material with another, it's about reshaping the systems that create, use, and recycle those materials. Imagine a world where every plastic item contributes positively to the planet rather than harming it. That vision is gradually becoming reality, driven by science, innovation, and a commitment to sustainability. The challenge now is to take action, both individually and collectively. Choose products made from bioplastics when available, support companies and policies that invest in renewable materials, encourage research into new feedstocks and compostable technologies. By doing so, we are not just imagining a better world, we are actively building it, one plant-based plastic at a time.